In this problem, we're going to represent the Blackline Master 69 with crayons. So in this pattern, in this first box, we have 4 crayons. 1, 2, 3, 4. And in this second 2 boxes will represent our second step or our second term, and it has 1, 2, 3, 4, 5, 6, 7 crayons. And in our third line of crayons, which would represent our third step, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 crayons. So we're going to look off of this function table, and we're going to try to find out what the rule will be for this function. So in our first box, we have the first one, we have 4. So in this function box, we have 1. The first step is 4 sticks, or 4 crayons in our case. And on the second one, we have 7 crayons, and on the third, we have 10. So when we go from 4 to 7, we're adding 3. So we're going to write plus 3, just like this. From 4 to 7, you're adding 3. So when you go from 7 to 10, you're doing the same thing and adding 3. So if we were to make a group of 4 and we want to add 3, it would look something like this. It would be our 4th term, so we would have 4 boxes together. And there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 crayons. So we're going to put 13 right here. So from going from 1 to 4, or from our first term, there's 4, you're adding 3 to get 7. Then from 7 to 10, you're adding 3. And from 10 to 13, you're adding another 3. So we're going to continue this for the rest of our graph. So 13 plus 3 equals 16. And 16 plus 3, right, you're going to write plus 3, is 19. And we're just going to continue doing this. So 19 plus 3 is 22. So now we want to find the 20th term. But let's write out our function first. So we're adding 3 times our term. But you have to add 1 more to get to 4, just like from 1 to 4. So in this equation, 1 plus 3 times your term. So we're going to call that x. So our rule is 1 plus 3 times x. So we're going to try this out throughout our entire function table. So 1 plus 3 times 1 equals 4. 1 plus 3 equals, or times 2, equals 7. Because 3 times 2 equals 6, and you're adding 1, and you're getting 7. So let's say we're wanting to try to find the 20th term. You're going to do 1 plus 3 times 20. Because 20 is where your x would be, and x is your steps at the very top. So 20 times 3 is 60. And you're doing 60 plus 1 equals 61. So your 20th term on this table is 61. And we could do that by representing with crayons, but that would take a really long time. So that's why we're using this rule of 1 plus 3 times x to equal your answer. So now we're going to figure out the 50th term and the 75th term. So now that we know that our rule is 1 plus 3 times x, we can use that to find out the 50th as well as the 75th term. So we're going to start out by writing out our problem. So 50, we're going to do 1 plus 3 times 50. So 50 times 3 is 150. So you can do 1 plus 150. So that equals 151. So we're going to write 151 under here. So now we're going to try to find the 75th term using the same rule, 1 plus 3 times x. So for the 75th, we're going to do 1 plus 3 times 75. So 75 times 3 is 225. So 75 times 3 equals 225. But now you still have to add 1. So your problem will look like this. 1 plus 225. And that is equal to 226. So we can write this up underneath the 75th term in our function table. So you can continue to use this rule up to as many steps as you want. But for 50, it's 151 crayons. And for 75, it's 226. We're going to represent this problem using sentence strips. So here's the problem. William and Sally put 160 marbles into a jar. William put in 83 of the marbles. How many marbles did Sally put in? So we're first going to start off by using the bigger sentence strip to represent 160 marbles. So we're going to write 160 marbles. So the orange sentence strip is going to represent 160 marbles. Now we have two smaller sentence strips which are going to represent the other two parts of this equation. The first equation is going to come from the problem that William put in 83 of the marbles. So we're going to put 83 on this sentence strip. So this is going to go right here, right above the orange one. So we want to find out how many marbles Sally put in. So we're going to put a question mark on this one because we don't know that answer yet. So there's 160 marbles altogether, and we want to find out how many Sally put in after William put in 83. So on this extra sentence strip, we're going to write out the problem 160 minus 83. Just like that. So to solve this problem, you're going to regroup from the 6 and make it a 5. So that would add a 10 here. 10 minus 7, 10 minus 3 equals 7. And then you're going to regroup again from the 1 and make it a 0, and this makes it 15. 15 minus 8 is 7. So from this answer, we concluded that Sally put in 77 marbles after William put in 83. So we can erase this question mark and make it 77 marbles. So from this problem, we can conclude that Sally put in 77 marbles from the sentence strips. And then in the subtraction problem, we did 160 minus 83, which equals 77. And the orange sentence strip represented 160 marbles, and both of these parts together was William putting in 83 and Sally 77 marbles.
Yep.
Okay, this is another problem that is going to be represented by sentence strips. There are 10 students in kindergarten. 3 are boys. How many girls are there in kindergarten? So the orange sentence strip is going to represent the total number of students in kindergarten, which is 10 students. So we're going to put this one underneath the yellow and the green one. So the green sentence strip is going to represent the 3 boys that are in kindergarten. So that will be over here. And now we need to find out how many girls there are in kindergarten. So the yellow strip is going to have a question mark on it because we are unsure of what that answer is. So first, we're going to figure out how many girls there are. So we're going to do a subtraction problem of 10 minus 3. So 10 minus 3 equals 7. So we're going to erase this question mark and put a 7. So since we have the subtraction problem 10 minus 3 equals 7, we know that 3 is smaller than 7, so we know that the bigger sentence strip that is going to represent 7. 7 girls. So using these sentence strips, it demonstrated that there are 10 students in kindergarten, 3 are boys, and 7 are girls. And so these two sentence strips, when you put them together, equal the same length as 10 students.